Hello, good evening, everyone.
Good evening, sir.
Good evening, Nikhil. Good evening, Soumya. Good evening, Aman. Good evening, Deep. Good evening, Arpit. Good evening, Saloni. Good evening, Priyanka. Polar vortex, jet streams. इसमें किसी को कोई प्रॉब्लम? Okay, good. अगर बाद में जब रिवाइज करोगे, ओके ओके राम प्रकाश, दिस इज योर फर्स्ट क्लास. Yes, Ram Prakash, you can easily cope up. Just watch those recorded videos. Okay, you must have those recorded videos. Just go through them and things will be easier. So in the last class, we were talking about the Kigali Amendment to the Montreal Protocol. Okay, in the Kigali Amendment, we are phasing out the HFCs. Okay, through the Kigali Amendment to the Montreal Protocol, we are phasing out HFCs. And we saw yesterday, for the developed countries, the timelines and the base year, they are different. The developed countries, they will begin the phasing out process in 2019 and they have to achieve it by 2036 for the developed countries like USA, Canada and European Union. And for these countries, the base year was 2012. Whatever production level of the HFCs was in 2012, and they have to reduce 85%. 85% of the 2012 level. They have to reduce the HFC production by this much amount. Then we saw for the developing countries like China, Brazil. Okay, for these countries, the starting year is 2024 and they have to achieve the targets under the Kigali Amendment by 2045. And for these countries, the base year was बताओ 2021. And for the third group of countries, which comprises countries like India, Saudi Arabia, Pakistan and the least developed countries, for those countries we have to start from 2028 and we have to achieve the targets by 2047. So 2047 तक सभी को अपने टारगेट्स अचीव करने हैं और for India also we have to reduce the production level by 85%. And base year for India type of countries, these are 2024 to 2026. Okay, this we did yesterday. और अगर मैं याद कर सकता हूं तो तुमको भी याद हो जाएगा. 2-3 बारी रिवाइज करोगे तो वो याद हो जाएगा. Okay. Now we are starting with the smog and the photochemical smog. I told you when we started with the ozone depletion that ozone, it is the main component of the smog. Ozone causes smog. Do you remember? I told you that ozone is a pollutant and it causes smog at the ground level. Okay, so we will cover the smog and photochemical smog. Yes, Nikhil?
Yes, sir, I remember, sir. You told in the last class.
Okay, very good, Nikhil. See, smog, it is a combination of harmful pollutants. There are some pollutants, and when those pollutants are released in the atmosphere, the group of those pollutants, it is known as smog. Okay, so this smog is a combination of harmful pollutants, and this combination it includes the nitrogen oxides, the sulfur dioxide, carbon monoxide, and the VOCs, volatile organic compounds. It also includes the particulate matter and the ground level ozone. So smog is a combination of all these pollutants. These pollutants, they exist at the ground level, and a combination of all these pollutants, it is smog. Okay, so the earlier when this term was popularized, when the smog was popularized, it was in the starting we called it as fog plus smog. Smog. What is fog? Can anyone tell me what is fog?
Fog means like when all this heat and all it comes in contact with ice and it, it can't escape, sir.
No, I'm asking specifically what is fog.
It's like
What you are saying is in those conditions the fog is formed. But what is fog? Yes, Arpit is right. Subhojit is also right. Nitin is also right. Fog is basically the condensed water droplets in the atmosphere. The small droplets of water in the air, that is fog. And in other words, fog is basically a cloud formed at the ground level. Fog is a cloud that is formed at the ground level. Clouds are basically the condensed droplets of water, and fog is also the condensed droplets of water at the ground level. Fog just happens at the ground level, and clouds, they are a phenomena of upper portion of the troposphere. Is it clear?
yes, sir.
Yes, Nikhil?
Sir, but this stratospheric clouds are different and these normal clouds are different, sir.
Yes, stratospheric clouds are different and tropospheric clouds, they are different. The phenomena of formation of polar stratospheric clouds, it is not very well understood. See, all of you must have seen when we put a cold glass bottle on the table, then within a matter of few minutes, we see the droplets of water aggregating on the bottle surface. सभी ने देखा होगा. Yes, Aman, that is dew. So the process of formation is same. The condensation happens on the colder surface, and that is why we saw the droplets of water aggregating on the bottle surface. The same thing is happening in the atmosphere. When the air rises in the atmosphere, we have the clouds formation. When the air rises in the atmosphere, it gets cooled down. The temperature of the air column decreases upon rising. As the temperature of the air column, it decreases upon rising, and this air column, it also contains the water vapor. So upon rising, the temperature of the air column decreases, and at some point, at some height, the water vapor present in the air column, they condense. So the clouds are formed. जैसे कि एक कोल्ड बोतल की सरफेस पे जाके एयर कंडेंस वहां पे हो गई, जो भी एयर के अंदर वाटर वेपर था वो कंडेंस हो गया. Similar fashion में when the air rises in the atmosphere, at by reaching a certain height, the moisture contained in the air column, it condenses, because upon rising there is a cooling effect in the air column. Okay, so a fog is a cloud that is formed at the ground level, and you must have studied in the high school physics, or if you have studied physics till class 12th, then can anyone tell me that why the air it gets cooled down upon rising? As the air column rises, why does it cool down? Why the temperature decreases?
Sir, because in the atmosphere it is very cold, sir. That's why.
Yes, Nikhil, in the atmosphere, as you go up in the atmosphere, when you go to the hill stations, there is a decrease of temperature with the altitude.
Yes.
And that is linked to this: when the air rises, it gets cooled down. That is the effect that we see, okay, that we see in the nature. As we go higher up in the atmosphere, there is a decrease in temperature. And that decrease in temperature, yes, Subhajit is right. It is because of the gas laws. You all must have heard about this adiabatic cooling. Have you heard about adiabatic cooling? Okay, Aman. No problem. See, when the air is considered as a bad conductor. Air is a very good insulator. Okay, air is a very good insulator, and when the air rises in the atmosphere, it does not exchange any heat from the surrounding. So for now, just assume that when the air column is rising, it is not exchanging any heat from the surrounding, because it is a good insulator. It is a poor conductor. It cannot exchange heat from the surrounding. So when it is rising up, it is doing some work. और जब भी हम वर्क करते हैं तो एनर्जी किसकी स्पेंड होगी? If I will do a 100 meters sprint, okay, my energy it will spend. So upon rising, the air column, it uses its internal energy, and whenever the energy decreases, the temperature also decreases. People, the major reason is this adiabatic cooling. When the air column is rising, it is not exchanging heat from the surrounding, and the air is using its own internal energy. And when the internal energy decreases, the temperature decreases. याद रखने की जरूरत नहीं है, जो याद रखने की एक जरूरत है वो बस that this process is adiabatic, and upon rising the air column it gets cooled down. Okay, Aman. See, please note down one thing, that whenever we will spend our energy, okay, our internal energy will decrease. Okay, everyone is with me? Whenever you will spend your energy, or any system will spend its energy, the internal energy of the system, it will decrease. And temperature is directly related to the internal energy. There is a direct correlation between temperature and internal energy. This is one thing. The second thing is, air is a very good insulator. Air is a poor conductor. So when the air column is rising in the air, in the atmosphere, it does not exchange any heat from the surrounding. Heat is basically energy. Heat is basically a form of energy, and when the air column is rising, okay, so in rising some energy it will spend, and because no heat is exchanged from the surroundings, okay, so it is spending its own energy in rising up. The air column, it is using its own internal energy on rising up. So when the air column it rises in the atmosphere, it uses its own internal energy, and its temperature drops, because the internal energy of the air column, it will decrease, and as the internal energy will decrease, that will express itself in the form of temperature. Temperature is an expression of internal energy. Because the air column is using its own energy to do this work, so internal energy of the air column decreases. Had the air been a good conductor of heat, it would have received the heat from the surroundings. Okay, whatever amount of energy was needed to rise up, it would have gained that much heat energy from the surrounding. So in that case, its temperature would not have been affected. The clear expression that as the air column it gets cooled down, it directly means that internal energy of the air column, it has decreased. I hope it is clear now. Always remember, whenever you will do some work, only your energy, it will decrease. Your energy will decrease. And this law applies to any system. Okay, whenever any system does work on its own. And similar is the case when the air, it descends in the atmosphere, so it expands. Okay, it expands, and the air gets heated. So do not go too deep into this topic. Okay, whenever the air will rise, only then the clouds will form. Nikhil, do you have any question?
Sir, that means if air if air was good conductor of heat, then global warming was not taking place, sir.
Nikhil, global warming is different. See, different gases, they trap heat. That is a different thing. But when air as a system, consider air column as a system, a discrete unit. And when this discrete unit is rising, then it gets cooled by the adiabatic process.
Okay.
Okay.
Thank you, sir.
Okay, Nikhil, welcome. So this smog, earlier it was considered as a combination of fog plus smoke. But now it is considered as a combination of nitrogen oxides, sulfur dioxide, carbon monoxide, volatile organic compounds, particulate matter, and the ground level ozone. Okay, and the normal smog is also known as the London type of smog. So in the normal smog, in the London type of smog, the SO2 is released primarily from the combustion of high sulfur coal from the power plants, or by the combustion of coal. There is SO2. SO2 is a primary component in the normal smog. So this normal smog is sulfurous smog because there is a large quantity of sulfur in the normal smog. Okay, there is some difference between the normal smog and the photochemical smog. Okay, so wherever there will be the high sulfur content in the atmosphere, we will have the sulfurous smog or the normal smog. Okay, so smog is a mixture of nitrogen oxides, SO2, carbon monoxide, and VOC. So it is of yellow-brown color. And what is this haze? What is meant by haze? Haze, a yellow-brown haze means haze is something which obscures the clarity of the sky. which obscures the clarity of the sky. Okay. So the phenomena that you observe in Delhi in October and November, that is basically smog. We cannot see clearly through the sky. And that smog is basically because of the stubble burning. What is stubble? In October and in November, in Delhi we have this situation of smog. No, Subhajit, it is not the waste part of the wheat, it is of the rice. Yes, primarily it is rice. So this smog, it is a man-made process. Okay, smog is a man-made process and it includes the burning and extraction of fossil fuels. And in this smog, the content, the sulfur content, it is high. And this is the phenomena of major cities. See, the nitrogen oxide, sulfur dioxide, there are natural sources of these pollutants. Okay, but in the cities, these are majorly released by the man-made sources. And the concentration of these pollutants, it is higher in the big cities where the large populations live. So smog in the modern times, it has become a phenomena of the major cities where large populations they live. And ozone is produced through a series of chemical reactions. In the ozone depletion, I also discussed that nitrogen oxides plus volatile organic compounds. It is a class of reaction, and in this reaction, ozone is formed. Okay, and sunlight also should be there. Okay, so this ozone is formed by the reaction between nitrogen oxides and the volatile organic compounds. And particulate matter, it is also formed through chemical reaction and some other processes. By the burning of fossil fuel or the incomplete combustion of any fuel, the particulate matter is also formed, and this particulate matter is of two types. These are the very fine particles, and we classify them as two types of particulate matter. One is with the size 2.5 micrometer and one is with size 10 micrometers. कितने मीटर होते हैं माइक्रो में? 1 micrometer is equivalent to yes, 10 to the power minus 6. Navya, 0.001 meter is 1 millimeter. It is 10 to the power minus 6. That is micrometer. How the smog is formed by natural processes. Okay, Nitin. See, whenever we have the volcanic explosion, okay, so in the volcanic explosion, the nitrogen oxides plus sulfur gases, they are released. Okay, and the nitrogen oxides, they are also released from the vegetation. So the major natural reason for the smog is volcanic eruptions or the forest fires. There are natural forest fires also. Yes, forest fires also. Okay. So what is the thickness of a human hair? To gain some perspective about the size of the particulate matter 2.5 and particulate matter 10, the thickness of a human hair is about 100 micrometers. The average thickness of human hair is 100 micrometers. So, under what situation, under what kind of condition, what kind of conditions can prevent this smog? Okay, if we have the windy situations, if we have the windy situation, or the wind speeds they are very high, then these pollutants they will scatter in the atmosphere. Okay, and within a matter of hours, the smoggy condition it will disperse. Or if we have rainfall, then the nitrogen oxides and sulfur dioxide they will mix with rain. They will mix with the rainwater and they form the nitric acid and the sulfuric acid, and they precipitate to the earth as acid rain. Okay, so rainfall also wash these pollutants out of the local atmosphere. So if in the smoggy situation we have a rainfall, then it will disperse the smog. If the wind speed they are high, then the smog will not be there. Okay, it will get scattered in 2 to 3 hours. So in October and November, the situation is that in Delhi, there is a windless situation. There is a windless situation. And atmosphere, it is mostly dry. There is no rain. So for October, November, and December, the situation is very bad. Yes, Disha?
You are now
No, sir, I was
unmuted.
trying to reconnect.
Okay, Disha. So this normal smog, it is also known as London type of smog because in 1952, we have this, the Great Smog of London in 1952 in December. And in those times, the coal was the major fuel. Okay, so we have this smoggy situation in London in the 1952, and in this situation, the 4,000 people died. There were direct deaths from the smog. 4,000 people died from the smog, and about 1 lakh people they fell ill because of this smog. So there was a windless situation for 4 or 5 days in London. But when the weather changed, okay, the windy situation reappeared and there was rainfall. The condition it get better. That is why it is known as the London smog, because 4,000 people died in that event. It remained there for 4 or 5 days, and in those 4 or 5 days, almost 4,000 people they died. Nikhil, you want to ask something?
Sir,
Yes.
so that means this smog is caused by burning fossil fuels in vehicles, sir.
Yes. The burning of coal was the major reason, and now we will see about the photochemical smog. Okay, photochemical smog is a bit different. So harmful impact of smog, you all know about it. It depends upon the amount of pollutant inhaled, the proportion of different pollutant in that smog mixture, and any health history of the individual. Now there is this thing, temperature inversion. The temperature inversion, it can make things worse. Okay, if a situation of temperature inversion arises, then fog will remain there for a longer duration. Does anyone have any idea about this temperature inversion? Anyone have any idea about the temperature inversion? Okay. No, Kritika, listen to me. See, we have this troposphere. Troposphere, the layer of the atmosphere in which all the weather phenomena happen. जिसके अंदर थंडर, लाइटनिंग, बारिश, साइक्लोन्स, ये सारे इवेंट्स होंगे. That is the troposphere. Okay, and above the troposphere we have the stratosphere. And I told you in the earlier classes that this lid of the atmosphere, this lid of the troposphere, it is known as tropopause, and air cannot escape to the stratosphere. This thing I told you. See, in the stratosphere, because of the ozone layer, because ozone is present in the stratosphere, and ozone, it absorbs heat. So because the ozone absorbs heat, the temperature in the stratosphere, it is higher than the layer below it. Temperature in the stratosphere is higher than the layer of air below it. And I also told you that as the air rises in the atmosphere, the temperature of the air column decreases. As the height of the air column increases, as the air column rises in the atmosphere, the temperature of the air column decreases. So जैसे जैसे air rise करेगी, उसका temperature decrease होता रहेगा. तो जब तक ये कंडीशन सेटिस्फाई होती रहेगी, okay, the air will rise up to when this condition is satisfied. If this condition is not satisfied, then air cannot go up. Okay, because at this juncture, at the tropopause, there is higher temperature in the stratosphere. So the air cannot rise above this point. Okay, because its temperature, it cannot further decrease. So the air, it will keep turning back from the tropopause, or the layer that separates the stratosphere from the troposphere. So this is one example of temperature inversion. Now suppose by any mechanism, okay, Aman, see, the temperature in the stratosphere, it is higher because of ozone. It is higher. The layer that is immediately below the stratosphere in the troposphere part, the temperature here will be lower and temperature in the stratosphere will be higher. Is it clear? And temperature in the stratosphere is higher because of ozone. The layer of air just below the tropopause. No, man. See here what is happening. In the stratosphere, as you will go into the stratosphere, see, this is tropopause. This line is tropopause. And the air above it, its temperature is higher than the layer of air below it. Because ozone absorbs heat, so in this layer of the atmosphere, the lower part of the stratosphere, the temperature is higher because of the presence of ozone. Okay, there is a temperature difference between these two layers. And the reason for this temperature difference is ozone. The temperature in the lower part of the atmosphere is slightly higher than the upper part of the troposphere. This was the point. And reason for it is presence of ozone. Okay. Yes, people. Air temperature will decrease with the increase in altitude, and reason for it was the adiabatic left frame. When the air column rises, okay, its temperature decreases. So it will rise up to that height जब तक उसका temperature decrease होता रहेगा. And because when it reaches the tropopause, the temperature above it is higher. इस एयर कॉलम का टेम्परेचर अब फर्दर डिक्रीज नहीं हो सकता है. द टेम्परेचर ऑफ दिस एयर कॉलम इट कैन नॉट फर्दर डिक्रीज बिकॉज द टेम्परेचर अबव इज हायर. So the air will turn back from this point. It will not cross the tropopause, and this is the reason that there is a distinction between troposphere and stratosphere, and all the weather phenomena they are limited to troposphere. As the air rises, its temperature decreases, but it will not cross this point because the temperature above is higher. The condition will not be satisfied. If it rises in the atmosphere, okay, its temperature should decrease, but in the layer above it, the temperature is higher, so it will not rise further. The air will not rise further because physics, the laws of physics, they do not allow it. So the air will turn back from this point. Again, this is a simplified version of a complex reality. Okay, there is no strict layer separating the troposphere and the stratosphere. Okay, this is only a schematic diagram. There is no. Yes, Sarpit?
Sir, a question, sir.
Yes,
Sir,
please.
but once we were studying these stratospheric clouds, sir, in
Yes.
that we studied, sir, the methane and NO2, sir. They go, sir.
Yes.
They react with this inactive
Yes.
reservoir of
Yes.
chlorine, sir.
Yes.
If
Yes,
this air,
Sarpit.
if air is not able to penetrate through this tropopause, sir, which is the topmost layer of this troposphere, then how are the airs which are getting inside this stratosphere, sir, and reacting with the
See, the gases they leak into the stratosphere through mixing, through diffusion. Okay, but on the larger scale, the air it turns back from the tropopause. But there is some mixing because of the air currents, because of diffusion. Okay, there is no watertight separation. In atmosphere, there is no watertight separation between the troposphere and the stratosphere. It is not like that. Nothing will escape to the stratosphere. There is some mixing to a smaller amount, and NO2, SO2, they escape. Okay, they escape to stratosphere as well, but on a very lesser scale.
sir, sir, this air, what we call, sir, it's a mixture of all these gases only, sir. CO,
Yes,
CO2.
yes, air is the mixture of all these gases.
Okay, sir. And sir, some gases will escape, but majority will come back, sir. Will be reflected back to the.
Some portion it will diffuse in the upper part of the atmosphere. Okay, some kind of mixing will always be there at the interface. The pollutants they may escape in the upper portion of the atmosphere, and they can also come back to the troposphere. It will keep on happening.
Okay, and sir, this temperature inversion is a regular phenomenon, sir, or it because it then helps in depletion of the ozone layer, sir.
See, this is at the tropopause. Okay, this is natural temperature inversion. But a situation, we may have a situation within the troposphere. If assume, if by any mechanism, if this is the surface of the earth, and by any mechanism, a column of air, it comes and it settles near the ground. And if the air above is warmer, then a temperature inversion situation arises. Okay, See, sometimes it happens during the night. People, because in the troposphere, the ozone is a pollutant. It is harming the plants. It is hampering the photosynthesis in the plants. Okay. It is also causing respiratory illness. And it is decreasing the overall productivity of the plants.
Sir, only one question more, sir. Then, sir,
Yes, please.
ozone hole being formed at the only pole, sir, and not being formed at the equator, this temperature inversion is also one of the then.
When I was teaching you the ozone depletion, I told you that the chemical reaction that was depleting the ozone, it was occurring all across the globe, and there should be a uniform ozone depletion across the globe. But the ozone hole is prominent only at the poles. Okay, and reason for that was the polar stratospheric clouds and the polar vortex. Otherwise, ozone depletion is happening everywhere because CFCs, they have a longer lifespan and they distribute uniformly across the globe. Arpit? Is it fine, Arpit? Nindya
Yes,
Jambal.
it's a clear.
Yes, sir.
Thank you. Yes,
Okay.
okay.
Okay. In India, temperature inversion is a situation in which we have a layer of air above the layer of a colder air, and this layer is warmer. A layer of warm air, when it is above a layer of cold air, okay, this situation is known as temperature inversion. First thing is this, temperature inversion is when we have a layer of air above the layer of a cold air. This situation is known as temperature inversion. And second thing, I told you that whenever the air rises, it gets cooled down because of the adiabatic cooling. So if a situation of temperature inversion occurs by any mechanism in the atmosphere, if temperature inversion has occurred, then the air, it cannot escape this lid. Okay, at this interface, the air cannot escape this interface. Or there will be some mixing with the upper portion of the layer. Okay, the upper portion of the air, there will be some mixing, but majorly the pollutants, they will remain only in this zone. So this temperature inversion, it prevents the diffusion of pollutants. Because of this temperature inversion, it prevents the diffusion of pollutants, and this smoggy situation, it gets worse, and it will prevail for a longer duration of time if a situation of temperature inversion is there. Because temperature inversion, it will prevent the mixing of pollutants, it will prevent the dispersion of pollutants. Again, if we have normally what we have, if this is the Earth's surface and you will go up in the atmosphere, then the temperature will decrease with height. The temperature will decrease with height. But in the case of temperature inversion, we have a layer of warmer air. Okay, if there is a layer of warmer air and below we have the cold air, the pollutants cannot disperse. Okay, they cannot escape this height. And for this reason, the pollutants, they will remain in this portion, and the smoggy condition, it will remain. Such kind of situation in the cities, it occurs during the night. See, during the night, the Earth's surface, it gets cooled. It gets cooled due to radiative cooling. So during the night, what happens? During the daytime, the Earth's surface, it will get heated up. the air below is warmer during the daytime. Okay, but during the night, sun is not there. Sun is not there during night, and the ground, it radiates heat, it loses its heat. So the ground, it gets cooled down at a faster rate. When the ground cools down at a faster rate, then the air column above it, its temperature also decreases rapidly. But the air above, its temperature, it is higher than the layer of air below it. So during the night, we can have this situation of temperature inversion, when the surface of the earth, it cools down by radiative cooling. So during the night, we have the situation of temperature inversion, and such kind of situation, they can occur in the major cities, and pollutants, they cannot disperse during the night. Disha, in Delhi, such kind of situation is for October, November, and December. The situation eases in January. So for 3 months, we have windless situation. In Delhi, we have a windless kind of situation. 3 months. You will study this temperature inversion in geography. Don't worry. Diffusion of smog is good because it normalizes the situation. See, if this is the area of a city, okay, the pollutants, if they remain in this area above the city, then the situation, it will impact the human beings living in this city. But if the air currents, they will disperse the windy situation, they will disperse the pollutants in the surrounding, and the fresh air column can replace this polluted air column. In the windy situation, what will happen? The fresh air column, this is the fresh air column, and it can replace this air column. See, you all must have noticed, if you have to face any kind of bad smell, what you do like this. ऐसा करने से क्या होगा? You are changing the air column. Okay, the air column that has those chemicals to which your nose is reacting, you are just changing the air column. The consequence of fog, Disha.
You are now unmuted.
No, sir, the one which you said that in Delhi, 2 to 3 months it is full of smoke. So what are the
Yes, it is full of smoke. The consequences are that you cannot do, the government, it releases some guidelines that you cannot even do yoga. Okay, in the morning, you cannot do the brisk exercises because your breathing rate, it will increase, and you will only inhale the pollutants that will cause only harm to you. You will not get any benefit by doing exercise in those months, be it jogging or be it gymming or be it yoga. If you are doing the breathing exercises, then you will inhale only the particulate matter, the ozone, the NOx, and the sulfur dioxides. So premature death. Yes, Disha.
So what are the measures taken by the government for that particular area?
See, this is a political matter, and things are related to the stubble burning and burning of crackers during Deepavali. Okay, so Diwali is an emotive issue, and stubble burning, because the farmers say they do not have any other option, create options for us, and then we will not burn this stubble. This is the argument of the farmers, and a lot many state governments are involved. We have the Delhi government, we have the Punjab government, the Haryana government, and the UP government as well. Okay, so they keep on blaming each other and the central government. So the situation, it is political situation as well, and because it is a windless situation also. So a lot of factors, they are responsible for the Delhi smog. We cannot control the winds. Okay, we can only prevent this stubble burning, but that will require the will on the part of political masters. Yes, Kritika, odd even scheme was there, but I don't think so. It has helped. It was also political stunt. See, all these political parties, they keep on blaming each other, and they just want to sustain their power. So no one has taken any concrete steps. Yes, Aman. If in Delhi after the Deepavali, we will see the situation. It will it will get very very worse. So the health impacts, I don't think I have to explain all these. We have covered the health impacts of the ozone. So all of these pollutants, the problems caused by them is irritation of the eyes, nose and throat. And all of these pollutants, they are responsible for decreased lung function. And these pollutants, they aggravate the existing respiratory and heart diseases. And it may even lead to death in some cases. Okay, so these are some of the general health impacts because of these pollutants. And now let us come to the photochemical smog. The normal smog, we call the normal smog as the London type of smog, and photochemical smog, it is known as the Los Angeles type of smog. So photochemical smog is also a smog. Okay, and it is a brown haze, and it is prominent during the daytime in morning, afternoon and evening. And densely populated and warm cities, because photochemical smog, it is just a type of smog. Okay, if this is smog, then this is photochemical smog. Photochemical smog is just another type of smog. So the major component of the photochemical smog, it is not the sulfurous compounds or the sulfur dioxide. The major component of photochemical smog, these are NOx and VOCs. And the major man-made source of the nitrogen oxides, it is the car engines, automobiles. So the car engine is the major source of nitrogen oxides and the power plants. Okay. So the component of photochemical smog, they are ozone is also there. We have the nitric acid, and this nitric acid is found. These aldehydes, they are derived from the VOCs, volatile organic compounds. The aldehydes, they are derived from these. We have PAN, peroxyacetyl nitrate. This PAN, it is also derived from the VOCs. PAN is also derived from VOCs. Okay. So these are the major pollutants present in the photochemical smog. So it is primarily caused by nitrogen oxides and vehicular emissions. See, vehicles are majorly responsible for photochemical smog, and obviously for the reaction to occur for the production of ozone, the sunlight must also be there. So it also requires the sunlight. Okay. So the normal smog, the difference is it is basically the sulfur smog, and it is caused by majorly by the vehicles. So we have a category of pollutants which we call as the primary pollutants. the primary components of photochemical smog. And these primary components are the NOx, nitrogen oxides, and the VOCs. These are the primary components. And all other components like ozone, PAN, these are known as secondary components. So these are known as primary because they are directly added to the atmosphere. And ozone is known as secondary pollutant. PAN is known as PAN as secondary pollutants because these are formed by reaction between the primary components. The primary components react with each other and with the sunlight